about that. Same thing happened last time, I guess. It's probably my Mac. Something stupid about it. I'm sure it's my fault. So we're going to go ahead and get started. This talk, if you went to the Breeding 10x talk and if you saw the keynote this morning, I worked really hard to not have a lot of overlapping content. There may be a couple of slides that if you were in the Breeding 10x talk, just kind of bear with me, because a lot of folks weren't in that talk also. But I did my best to really make this, more of a unique talk. It comes from a stripped down, like 4-hour workshop. So there's a lot of content in there for us to get through. So we're going to move at a pretty fast pace. It's obviously I cut down a lot of the content too. But we'll see if we get through this. And because of the weird HDMI issues, I don't want to be rude, but when I do my demo, I have one demo, and I'm going to do it with my back turned to you on my knees over there by my laptop. But for the rest of it, I can use the clicker. Okay, so this is more of a deep dive into the practice of developer productivity engineering. Who now at the conference, coming by the Gradle booth or seeing the keynote this morning, has a better idea of what DPE is? Oh, excellent. That's such good news. Yeah, that means I did my job. I can go home. So, no, we're going to dive into it. This is more of a 102 type of course. So we're going to get a little bit more granular. A lot of the concepts are going to be the same. So I'm Justin Reock, Field CTO, Chief Evangelist, Gradle Enterprise. For those who haven't been introduced yet, background in software development, moved into enterprise architecture. Now I do PowerPoint. So the philosophy that we really espouse at Gradle around developer productivity engineering is that developer joy equals developer productivity, which equals business throughput. Okay? We see these things as the same thing, right? A joyful developer is a productive developer, and a productive developer is joyful because they are productive. They get to do what they want to do and stay in their state of flow as often as possible, and that will create more business throughput. And this is way more important now than it's been than ever, really. This is stale data. I'm waiting on IDC to push the 2023 report, but this prediction came true that by 2022, we would be 65% of the global GDP would be digitally transformed, which is a staggering statistic, all right? This workforce is holding up 2/3 of the global GDP, so no pressure. A lot of you may have read that back in June, we were able to decode the remaining 8% of the human genome. Right now, obviously, it took geneticists, scientists, people in the medical field, but they could not have done it without being able to construct digital twins of the genome. And we will now be able to run simulations against this genome that could potentially show us where the next novel pathogen may arise from, and we can print vaccines for it before it even shows up in the wild. Okay, so, and none of this would be possible were it not for software, were it not for the infrastructure that we create. And so really the best code is written by happy developers, and so we should strive to foster developer joy because innovation augments and helps us solve some of the biggest challenges, right? There's a direct correlation now between the quality of our code and the quality of our lives, all right? And we need developers that are engaged and happy and productive to do that. But instead, enterprise software development has created really a unique set of challenges for us. Instead, there's sort of an irony or sort of a tension in play, which we talk about as part of DPE, which is that as a software project becomes more successful, more developers working on it, more lines of code, more dependencies, more tests, the developer experience gets worse and worse and worse, all right? So the more successful, the more widely adopted, the more activity there is around this project, slowly that developer experience begins to degrade, right? And we really have to be cautious of this. This was one from, if you were in the other talk, you saw it, but a lot of people look at this and they're like, oh, actually, I wish that my schedule looked like that, because where are all the meetings? But just kind of bear with me here, that a developer is going to be up coding in their state of flow, in their state of ecstasy, where they want to be, and then they have to wait for their build to complete. And then it fails. So then you get to spend the rest of the afternoon debugging that. And you go blow off some steam with some Elden Ring, or I'm personally playing the new Zelda right now. And then you get back to coding. And you're in your happy place. You're great. And you debugged the failure. So you do have to wait again, but your build completed. So yay, we get to push it to CI and wait again. And then it turns out that the test failed in CI. It ran on our laptop, and now we get to spend the rest of the afternoon debugging flaky tests. We've got to do better than this, and we can. So what if we could cut average build and test time in half, right? What if we could do that? What if we could decrease build and test failure time to resolution by over 2/3? And what if we could get 100% of the visibility to data that we need to see what's going on with our builds, both locally, remotely, and in CI, right? And that's the promise of developer productivity engineering, which effectively applies engineering techniques to productivity management, right? Instead of leaning on developers to crank out more lines of code, or even to try to shuffle their meetings around and give them some more focused time, instead we treat the development environment in which the developer is working as if it were a production environment, right? We're monitoring it, we're capturing telemetry from the builds, we're understanding through data what the developer experience looks like. And so we're focusing on faster feedback cycles, more reliable and actionable data, and ultimately a highly satisfying developer experience. For those of you who were in the Breeding 10x talk yesterday, you saw that I brought up the space metrics, right? And we found out that in the most recent study on space framework, there was like single-digit concern for the S part of space, which is satisfaction, right? But this is definitely part of what we're trying to engineer through DPE4 developers. So to use kind of a bad metaphor, but that hopefully sort of gets the point across, traditional developer productivity management focus is going to be on the driver of the formula car, all right? We're managing the person, right? Developer productivity engineering is looking at the tires, the engine, the other parts of the car. I'm not a car guy, I don't understand. But it's about making sure that the car is as optimal as possible for the driver, right? That's kind of the difference between traditional productivity management and what we try to do with developer productivity engineering. You notice it's Oracle's Formula One car too. I thought I'd throw that in there. All right, so really you can sort of think of this as a continuous improvement flow. We're identifying and removing whatever impediments there are to developer productivity, things like feedback cycles and flaky tests and all this stuff, to be able to get us faster, more consistent, more reliable, right? The reliability really matters, right? If you have a bunch of avoidable failures, infrastructure failures, flaky tests, people are going to lose faith in all of that testing, and ultimately they're not going to do it, right? Or they're going to find workarounds around it. We're a clever bunch. And you need to have consistent feedback cycles too, because if you have a build that's like, oh, it's a minute, it's not bad, but every now and then it runs an hour, we don't really know why. Well, guess what? The mentality is going to be, this could take an hour, so I'm going to cram a bunch of code in anyway, even if it's a fast build. So we have to have consistency here too. So, developers don't show up to fail. Nobody shows up to fail, right? Developers want to work in an environment that enables them to do the work that they love, which is coding, as often as possible, right? That's why we signed up for this, right? Organizations that cannot provide this kind of environment, they will lose talent. They are losing talent. In fact, Valley Bank, which is actually a smaller one of the banks in the US, had a really interesting perspective on this. The guy who founded that bank actually came from a software company. And he said, you know what? We're going to build a bank, and we're going to comply with regulations and all that stuff, but we're going to focus on developer experience, right? We're also going to make sure that the developers have really good tooling, that they have a comfortable environment in which to work. They stole some of the best talent from other developers that were working in big banks, the Capital Ones, the Goldman Sachs, the Scotia Banks. He just went in and took some of their top talent, all because he focused and advertised on creating a better developer experience, doing it intentionally. So we need this. We need it right now. We need it because 65% of the global GDP is held up by this workforce. We need it because this is the most important, arguably, workforce in the world, lifting all other boats in the harbor. And we also need it because it's the right thing to do. If we have formula and techniques that can make a person less cognitively fatigued, enjoy their job more, and we don't apply those things, it's a moral imperative to do it. So you have to create a culture where the whole organization commits to this effort, and you need to have a team of experts. A lot of times people are like, what do you mean a team of experts? That's centralization. That's an anti-pattern. You're thinking in DevOps terms, right? Ultimately, the platonic ideal for a DevOps team is no team at all. Bots, automation, that kind of thing, right? But for a productivity engineering team, you have to have a human with empathy for the developer experience, or you will not get the sense of urgency. And you need a leadership mandate, or else it won't be the full realization of this won't happen. So priorities and success criteria has got to be based on data that comes from a fully instrumented tool chain. Again, treating our development environment like a production environment. And it fosters developer joy. Should be no surprise, right? You eliminate friction, toil, frustration. And suddenly, people are happier at their work. Now, this 81% statistic doesn't mean the 19% were like, no, DPE sucks. You know, they just were kind of like, don't agree or disagree, or don't know what DPE is, or didn't realize we were doing DPE, something like that. So, still, though, pretty high amount of people who would have sort of agree with this. So, as a framework, DPE really addresses 5 major pain points. We've talked about feedback cycles, not going to beat that anymore. Inefficient debugging, or I don't mean debugging your code in your IDE. I mean like troubleshooting a failed build or a slow build, right? And we don't really have a lot of efficient tooling to help us do that. Flaky tests and other avoidable failures. No metrics, no observability. I asked the question before, and if you were in the breeding talk, sorry, but I always like to ask, who in the audience is even tracking local build times? A couple of people. Yep. And I mean local. I don't mean like Jenkins is giving us, data from what's happening in CI. I mean tracking what developers are doing on their laptops, right? We're going to talk about that. We're going to revisit that. Because you can't, expect to improve this or have any kind of urgency if you don't have the data that's showing you this. So, and you can't keep your system performant without continually sort of being vigilant over it. So we need metrics. And then finally, inefficient use of CI resources. Is this part of productivity? Not really, but it's a side effect. And we'll explain kind of how that works. All right, so let's start with pain point number 1. Fast feedback cycles are important, but often we don't really explore sort of all of the effects and new behaviors that we see by improving our feedback cycle times. So there's obvious stuff, right? Less idle and wait time, which means less context switching, right? You'll hear me talk about literally the brain toxicity that occurs as a result of too much context switching, right? And this is a really slippery beast because, switching your focus is associated with a increased amount of glutamate, the toxin, in your prefrontal cortex, which is also directly associated with cognitive fatigue. But cognitive fatigue is hard to detect because a person can still do their basic tasks, but it's really hard to elevate the work that they're doing. It's really hard to innovate. So there's a direct relationship between too much context switching and global innovation. It's actually not hard to connect those dots. More focused developers, better productivity, better quality. But then there's some stuff that's maybe not as obvious, right? So if you're shrinking your build times and test cycle times from 10 minutes down to 15 seconds, well, developers are going to build more often, which means we're going to submit smaller change sets. We're going to have smaller merge requests, so less chance of merge conflict, right? This is going to lead to faster mean time to resolution down the road, and then ultimately, again, to quality and productivity. So really just focusing on fixing this one thing can have these very positive cascading effects and behaviors that affect a lot of other areas of the business that are not always, not always so obvious. I see a couple people taking pictures. I'll give you a chance to do that. We'll also get these slides to you. Okay, so I really like this quote, and I'm going to have to turn around and read it because I'm not on my laptop, but I don't want to mess it up. It's about the state of creative flow. And what I like about it is this is not written by a programmer or a business analyst, right? Laura Jaworski's an artist and an author, all right? But flow state is universal to something that you're passionate about. So it isn't about being the best, because once you tap into the creative flow, the best doesn't exist. It's about experiencing the magic. It's about being in that place where your heart is free. It's about grabbing hold of the intangible and making something beautiful, okay? And I think we know what that feeling feels like. Cal Newport, a little more professional, talks in his book Deep Work. Professional activity performed in a state of distraction-free concentration that pushes your cognitive capabilities to their limit. These efforts create new value, improve your skill, and are hard to replicate. Who's familiar with Cal Newport? Oh, wow. If you're into productivity, look this guy up. Really, really interesting theory and ideas. Yeah, and Deep Work is the book that I would recommend. Yeah, really an inspiring and very smart person. So at the end of the day, quality of creative flow plus collaborative effectiveness equals team productivity, right? I think that's a pretty simple formula. We got to get out of this mentality again. Sorry for the joke, but and I think like 15 presentations have had this slide in it at this point now. But like I always say, this is funny and sad simultaneously because of the truth of it, right? We really can make this better. We also have this situation now too. Sure, 90% of the build cycle is going to be caught up in testing. Sinking feeling that we might be getting here eventually. All right. So let's put some math behind this. So these are actually real numbers that came out of a couple of teams that we were doing trials with on our commercial product. And I want to point a couple of things out here. Take a look at what's going on with this team of 11 people with a 4-minute build time. They're running about 850 builds a week. Okay, take a look at this team of 6, just a little more than half the size, with a 1-minute build time, achieving over 1,000 builds a week. This team of 6 is able to refine their work and ask for feedback about their work more often than this team of 11. So a couple of things here. First of all, this makes a big difference. But also, who's complaining right now about a 4-minute build time? Right? Nobody. We should be. You should be complaining about it. Like I said yesterday and maybe this morning, you should demand that the build and test cycles are as fast as they can possibly be. Why be lazy about that? Right? Sharpen your axe. Looking at a bigger scale here, who's complaining about a 1-minute build time? Nobody. But look what happens when we took this team of 6 from a 1-minute build time down to 0.06 minutes. It returned 44 engineering days of value a year, which to a small team, that's a lot of time. That's like 2 full vacation cycles. And then looking at this large team, the scaled team, 12,000 local builds a week that they're running, 100 devs, taking a 9-minute build time down to 5 minutes. Maybe not perfect, but it returns 5,200 days of engineering value a year back to that team. All right, it's a no-brainer. So the faster the build, the more you stay focused too. You know, as build time increases, you context switch more often, and the cost of context switching has to be paid, and multiple times, really, whenever you work on the previous task. Whenever the build fails, whenever the build was necessary to provide that feedback, every context switch costs about 10 to 20 minutes. And it has to be paid twice, right? New task, fix build a previous task, start new build, go back to new task. All right, that's twice. All right, that's up to 40 minutes of useless time, right? So a reliable tool chain, an unreliable tool chain increases this cost. So if you add, these feedback cycle times and all this context switching, and then on top of it, you add a bunch of avoidable failures and flaky tests, now we're really talking about a lot of toil. And I want to make sure everybody understands what I mean when I say toil. It's a very, very intentional definition. It's engineering work of no value, right? That's what we're trying to eliminate, is toil. And developers will put up with a lot of toil, right? I'm going to reference a blog from Netflix in a little bit that was co-written by a productivity engineer at Netflix named Danny Thomas. And when I was interviewing him for this, he said something that is, it's etched in my mind, and I use it in a lot of my talks now because I think it's so apt. He said, it is staggering the amount of toil and friction and frustration that engineers are willing to put up with. And I think I kind of understand why. When I was coming up in the 90s doing software a long time ago, it was a badge of courage to be like, oh yeah, I wrestled with the code all night. Oh, I cranked out 100,000 lines of code. It was great. And there was this sort of, superiority of the fact that we were able to do this, that we were able to put up with this. But then that sort of became then sort of a fixture that changed kind of the patterns of our industry. And now we see these things sort of as occupational hazards of the job. Like, we just have to put up with this. It can't get any better, but it can, right? And it can through DPE. So let's start getting into some of the actual technology that can make this work. First is going to be a build cache. So build caches are not dependency caches. So if you take one thing away from this talk, know that a build cache is not Artifactory. It's not Sonatype Nexus. These are complementary products, but they're not the same thing, right? A build cache is effectively going to take phases of your build and cache the outputs against a hash key that's generated from the inputs. So that instead of having to run that part of the build every time, if you haven't modified that part of the build that would create that part of the artifact, you don't have to run it. It'll pull that chunk from cache and stick it into the artifact and save you a lot of time. We're going to do a demo of this. It works again right now. Gradle, Maven both have build caches. Gradle's was introduced in 2017. And you pass these inputs in, and you pass them to these tasks, and they create some kind of output. If you ever dug into the way that Maven interprets its POM file and runs its goals, or the way that Gradle actually defines and runs its tasks, there's standard set of inputs that get passed into the task and a standard output that's created, right? And so that's how we're able to do this caching. We're able to look at the inputs, create a hash, and then store the outputs against that key. So to construct it a little bit more programmatically, we're creating a cache key from, in this case, a Java compile task. And what would we want to hash in there? What would those inputs be to a Java compile task? Well, what you would expect. Source code files, JDK version, class path, compiler arguments. And then when that task completes, what do you end up with? A file tree of class files. So that's what we stick in the cache, right? Now, it's hypersensitive. You know, anything changes, even remotely, and we're going to look at some of the input volatility in a moment, you will get cache misses. But obviously, that's better than pulling bad data into the artifact. And we can cache a lot of stuff. A lot of different inputs that can be cached are things like test source files, Maven, like inputs that you would have to something like Gradle test or Maven Surefire test inputs would be things like the test source files, runtime class path, Java version, check style inputs, because you can cache check style tasks too as well, source files, check style version, check style config, and caching is kind of generic. It can apply, hopefully, to any task that's not I/O bound, right? So you're not going to task like packaging up the jar file, or you're not going to cache like packaging up the jar file or doing cleans or copies or something like that. But there's a lot of possibilities here. So to go sort of like a couple of scenarios around how this caching works, then we'll look at a demo. Just kind of imagine that you've got two separate applications. They're multi-module applications, and you've got these 4 modules. The caching obviously is going to work best when you have a modular application where you can be working on just one area of the app. So in normal context of things, whether doing a Maven build or whether doing a non-incremental clean Gradle build, change anything, you got to rerun everything. Okay, rerun the whole build. To take a quick look at how this is structured, export API depends on core, service depends on core, web app depends on service, nothing depends on web app, nothing depends on export API. Okay, so what happens if we change a public method in export API? Well, we have to compile it again. We got to compile the test. We got to run the test. We got to do check style. But everything in green we could pull from cache, because that's not going to change. When we go through and run it a second time, the input hash will be generated the exact same way because none of that stuff changed, unless you have some volatility, which we're going to get into in a second. Service, changing a public method. All right, so a visible public method. Yeah. Exactly. Well, but it's not even that the cache knows that. It's that you're generating a key from inputs that have changed. So you're generating a new key. But when you go and look at the other tasks that you're pulling from cache, you generate a key from those inputs, and you do get a match inside of the cache, and you can pull that. So it's not actually paying attention to any type of graph or anything like that. It's just the key mechanism. So okay. So changing this public method means we have to recompile service, test. We have to recompile the test, run check style. The dependent module, because this is a public method, has to be compiled, test compiled, run the test. But everything else can still be pulled from cache. You know, you're getting the gist here. We change an implementation detail, not a public method in the service module, then we don't even have to compile its test anymore because it was an implementation detail. We didn't change anything that would need us to recompile the test. We have to run the test, check style it, run the test on the dependent module, and everything else comes from cache. You see how this is going, right? And then even the most like sort of invasive change you could make, like a public method in the core module, at the very least, you're still pulling these check styles from the modules that haven't changed from cache. All right, so where can this all kind of bork up? Well, when inputs change. Right? And there are lots of things that can cause inputs to change, right? Inputs need to be standardized and they need to be portable, right? A lot of what our solutions engineers do for folks who are, you know, trying to get their head around the cache is help them debug cache misses, right? Why are you generating a .properties file with a timestamp in it? So because of that, this next run has a file in it that's not going to match, and it's technically part of the source, and so it's not going to pull from cache, right? There's other things too that can happen. You might have weird code generation going on. You might be hard coding absolute file paths as opposed to using and that will matter because the path of the file is going to get passed in. Any kind of non-deterministic ordering of the build, right? So if you've got any randomness in the way that the build actually executes, and there's a million other weird scenarios. If you look inside the Gradle build cache training, which is in our docs. We have really good documentation, I have to say. A lot of open source projects don't, but we really do. You can get tons of information about all the different scenarios that can really screw up your cache, and nice ways to fix them, and nice ways to normalize away things that you can't fix, right? So you can see a lot of that in the documentation. We also have a training. If you go to our Gradle.com site, you go to events and training. These are all free. All of our trainings are free, and they're online. And we have one that's called the Build Cache Deep Dive. And so if this is interesting to you, you go a whole hour just diving into just the build cache and really exploring even more of these types of scenarios. So how does it work? Well, it uses a local cache directory that's just sitting on your machine, and it speeds up development for a single developer or a build agent, and it reuses build results when switching branches locally. But at the end of the day, it's sitting there in your .gradle directory or your .m2 directory if you're Maven. All right, let's look at a quick demo. Again, I'm not trying to be rude. I apologize for turning my back to you, but it's the only way that I can manage to pull this off. Also, don't yell at me for using VS Code. I also do Node.js work and other things. I know IntelliJ is better for Java. I would never argue that. All right, so let's take a look. This is we're actually going to do a Maven demo here. Oh, that's pretty big. A little bigger, I guess. We're actually going to do a Maven demo here just to kind of demonstrate how that works. Plus, I kind of like this demo application. It comes from a camel spring router archetype in Maven. So what I like about it is it's simple and it compiles pretty fast, but it has a full life cycle. Right? It's got a set of unit tests and all that kind of thing, but it doesn't take forever, right? But you can still get a sense of sort of proportion of how you can make this better. So the first thing I'm going to do is delete my existing cache, which is sitting here in the there's a lot of lag, wow. Sitting here in the M2 directory in .Gradle Enterprise build cache. I'm going to blow that away just to make sure that it's clean. We're going to run a Maven clean verify because we don't do Maven installs. And this is going to take 15 seconds or so. You can kind of see the life cycle here. We're running our tests, right? And so we executed in about 10 seconds, which is actually a little faster than this thing sometimes executes. But let's run it again with caching. Yeah, no surprise there, right? So we saved about 70% of our build time just by using caching, right? And this is not like a seriously, modular build, right? This is a fast build. But if you had a very modular build that was taking 45 minutes to package, you could see that this could have a really tremendous impact, right? So if we had more time, I would dig into some of the internals of this. But again, there's a lot of content. And I want to really try to make sure I get through it all. Wrong presentation. That was from the one I did in Zurich a couple of weeks ago. Okay. So that's how it works. Simple, but you can really see kind of enormous savings. There are a couple of Maven caches available. There's the open source one that's generally available since, I want to say, late November last year. It works pretty well. I've experimented with it. We are integrating it into, or information about it into our platform. And then Gradle Enterprise ships with a Maven cache as well. Kind of a quick note. There's also the ability to use a remote cache node. If you go in Docker registry, you can actually see, if you just search Gradle remote cache or something like that, just search Gradle in Docker Hub, because I think there's only a couple of things in there. You can actually deploy this completely for free. Now, Gradle Enterprise obviously provides some value adds. I won't get into them because it's not a sales pitch, but the bottom line is you can set this up without paying us a dime as part of the open source stuff. So what effectively this allows you to do is have a remote cache node, which is great for really two things. On the one hand, it's good for if you're running a distributed environment with CI and you have a follow the sun model, right? A lot of you are familiar with that first build of the day, which kind of sucks because you pulled down all these changes that came in overnight, and then you hit go and you go away for an hour. So as your first executive decision of the day, you have done nothing. Instead, you can benefit from a remote cache that's been populated overnight by CI, and you can actually still pull entries that were created by other developers, right? So it's a really good use case. It's also really good for ephemeral build environments that are going to blow away their local caches, right? If you're using like GitHub Actions, or if you're using Jenkins or some kind of CI with ephemeral container builds, then obviously the local cache isn't going to work on those CI nodes, because as you saw, it's sitting there in the home directory, right? You blow away that environment, you blow away the cache. But if you set up a remote cache node, then those ephemeral environments can still take advantage of it. All right, so that's caching. Test distribution is the second thing that we recommend. We have existing solutions for running our tests in parallel. Right? This is effectively what this is about. Right? Once the cache has gone through and cleaned up, part of what's going to execute, obviously there are still things that are going to need to run. right? Tests that are going to need to run. It's not like we're going to sit there and never change our code. That would be great if we never had to change our code, but obviously we're going to. So there are going to be tests that are going to have to run. So we may as well run them in as much parallelism as possible. And there's different approaches to this, right? You can use the parallel flag within Gradle to have workers running locally on your laptop, or you could set up a CI fan-out kind of pattern where you have created your own parallel pipeline and you've manually partitioned your test sets. But this is really a better solution because it doesn't have a limit. You know, the limit's how much you want to pay for cloud cost, and it works for local builds and within CI, right? So it benefits the developer right there at their laptop, not necessarily only in a CI build, right? And it's a very straightforward mechanism. You set up some Docker agents that are capable of running a JVM and running a JUnit test, and you stick them in a Docker image, and you throw them out in Kubernetes, and you come up with a way to have your build tool schedule those tests. You could do a plugin or something to schedule your tests out to these distributed agents. And if you want even a preview, if you want to kind of pull down see how we put ours together, these are also on Docker Hub, right? So if you're curious about what a test agent would look like in your own distributed test setup, if you wanted to DIY it or build it yourself, you can get some hints there if you want. Just go to Docker Hub, search Gradle, you see the test agents, you pull it down, pick it apart, have fun with it. But what it lets us do then is scale up as much as we want. And because we're using a KDA horizontal pod autoscaler, which is a Kubernetes native way of taking a pod and scaling it as necessary, you let Kubernetes do the work of increasing the amount of tests that can be run in parallel. So it's better than these other solutions. Build caching is great, obviously, but things will obviously change at some point. Single machine parallelism is limited by the resources of that machine. Even if you have an awesome M2 Mac, you're still going to hit a limit. And CI fan-out doesn't help during local development. You have to manually partition your test sets. You have to figure out a way to get the results from the test back. It's just a lot of jankiness, right? Much cleaner implementation to do something like a test distribution architecture. And if you're curious, this is what I mentioned earlier. Danny Thomas from Netflix was able to, he's a developer productivity engineer. That's his title. And they have a big team of them at Netflix, and we're going to get into why that's important. They took a 62-minute test cycle time down to under 5 minutes. I mean, can you imagine how much that has fundamentally changed the way that this team is able to work on this project? And it was really just two. It was just caching and test distribution that they used kind of in tandem. So you can really get some amazing results. And then finally, machine learning, our third acceleration technology that we recommend. Gartner has, I have a seat at Gartner. Part of my field CTO work is to do analyst relations for Gradle. So I consume a lot of analyst content. So I know this isn't always like the most developer, like why do I care about this? But it's kind of interesting to see the trend. So Gartner has these things they call use case prisms. And in this case, they're saying how are people going to use AI in software development and testing? And there's a lot of different potential applications, but the two that we're going to talk about now are test set optimization and optimal test selection. Yeah, what's that? Oh, yeah, right. Yeah, for sure. Test self-healing too, yeah. So, I mean, really, there's a ton of potential here, as we all know, right? I mean, AI is about to eat the world. But what we're going to talk about now is a technique called predictive test selection, which we did not invent. There's a really good white paper on this that Facebook provided, Meta, I guess I should say, provided. This was cooked up in the labs of Google and Facebook. We did productize it, but this manual will tell you how to build it from scratch, even recommending what machine learning libraries to use, which in this case is one called XGBoost, which is a gradient boosting machine learning decision tree based, like forest based type of learning model, if you know much about learning models, which means it's not a deep neural network, which means you don't need a GPU. It'll just work right next to your build stuff using a CPU. And again, there's the blueprints for this are in here. So it uses a predictive model to try to evaluate the usefulness of a test from the test set. What do I mean by the usefulness? Is it going to change its output from the last time it ran? More likely than not, what we're really talking about is this test going to fail? If I run 20,000 tests, let's take Kafka as a great example. Kafka, the open source Kafka project, has over 24,000 tests that it runs. And it takes like 45 minutes for it to do that, right? And you run those 26,000 tests and you wait 45 minutes and you're like, all right, it was good, but what a waste of time, Everything just succeeded. I don't have any valuable feedback from this. So only run tests that are likely to provide valuable feedback pre-merge. Don't get scared, right? Post-merge, run everything. This is really talking about the more local experience while you're at your laptop. Test cycle times can be reduced by doing this. So more conventional test selection approach is this. We're all familiar with this, right? These little diamonds at the bottom are modules, and then dependencies, and then tests. And if we change part of the code, and one of these tests depends on it, we're just going to be paranoid and run everything, right? Even if everything just succeeds. Because we don't have a better way, right? We need to test stuff. This one didn't change, obviously, so we don't run 5 and 6, but there's probably a lot of redundancy here, okay? Again, yeah, do this in pre-merge environments, not post-merge environments. Post-merge, run everything, because the models aren't perfect, right? We've got them in pretty high confidence. Spring, actually, this week has been at 100% confidence with its failure detection. Micronaut uses this, they're like 99.8 or something like that. I'll have some screenshots later to show you some of the results of these. But yeah, do this pre-merge, which is where you get the most value. And how does it work? Much differently, right? It takes a look at this trained model, this decision tree forest, and it says, okay, based on the types of changes that were just made, which are features, right? I'm going to look at a history of when similar features were changed and came into the model and just see how the test behaved in the past. And I'm going to generate a probability score of whether this thing is going to fail or change its output. And if it's not going to, well, I'm just not going to run it. From a kind of a more graph, this comes from the white paper. A code change will happen. Features will get generated from that code change, things like file extensions and historical failure rates, and even the project name, interestingly, is a useful feature. And then it's going to make a prediction about the probability of failure. It's really just how it works. So you can see some of this. This is Micronaut Foundation. They've been using our version of this for free. We have a program where we give our product away for free to open source projects, and we did it here. And this is a month-long period. Serial, this is not wall clock time, right? Because a lot of this is parallel execution. But 46 days and 53 minutes of savings potential. They didn't have it turned on at this point. But this is crazy. Look at the collective amount of time that's saved here by not having to wait while these things run. Here's Gradle. Now, those who have maybe tried to contribute to Gradle or anything like that, we run a lot of builds, okay? So we actually, right now, from this data, we obviously dog food our own product, 56%, 1,600 days of serial collective test execution time that's been returned in this 1 month period. It's insane, right? JUnit's using it as well. They don't run as many builds, but they're still seeing some good savings here. 48%, 7 hours and 18 minutes in this week-long period, right? So like a working day. And so at the end of the day, you can kind of think about all these things operating together as force multipliers, right? They're all going to help each other. The build cache could start by, let's go back to Kafka. Let's say that we can pull 20,000 of our tests now from cache with Kafka, and we're down to 4,000 tests. Now we can run predicted test selection against it and find out that we really only need to run 500 of those. Then we can run 500 of them in parallel using test distribution. Right? So in this force multiplier, we're starting to talk about 40, 50, 60x gains in performance in your build. All right, pain point number 2, more efficient troubleshooting. Am I going to make this? Yeah. The rest of it actually goes pretty quickly compared to the caching stuff. It's probably the most complicated part. Efficient troubleshooting of builds, both performance and failures. Right? Builds have gotten really complex. You may have noticed, right? Especially Gradle builds. It's not lost on me that the flexibility of having the full power of Kotlin or Groovy at your fingertips to create your build configuration is very much a double-edged sword, right? We give you a lot of rope to hang yourself with, and you can create some extremely complicated builds, right? And that's okay. We just need good telemetry. So we want something that's self-service and collaborative. We want something that is quick, gives us a quick root cause analysis. We want something that can decrease the mean time to resolve of a build failure, right? And this is one of these ones where there's really cross-benefit now across CI teams and developers. Because CI teams are on the receiving end of all these tickets that get generated by, especially at scaled teams where you have like a CI organization that's supporting like 300 developer teams. The CI folks are just seeing tickets come in every time builds. We're not really considerate, right? We're just like, build failed, and open up a ticket. You don't realize that there may be thousands of other ones that are doing the same thing. And even if it takes the CI folks 5 minutes to go find the piece of data that they need to throw back at you so that you can fix your build, it would have been much better for you to have that visibility. So for us then, it's our free build scan, right? This thing is totally free. Like Grubhub, for instance, is shameless about telling us that they've hooked this thing up, our free version, to their automation, and they automated away all the stuff that they would have gotten if they'd actually bought Gradle Enterprise, which is like, fine, okay. They're running like 3,000 of these a day. You're welcome to use them, and you get all the data that you would need to be able to troubleshoot a problem with the build. And this is especially useful going back to what I was talking earlier about ephemeral environments that disappear, right? It's kind of hard for you to be able to get your hands on the data. What are the CI guys going to say? Oh, could you run it again and see if you can reproduce the problem, right? But no need to if you've captured all the environment data that you need to solve what's actually wrong with the build, right? Now, if you don't want to use build scan, or if you're like, I hate Gradle Enterprise, use this as inspiration, right? Run one, see what kind of info it's pulling out of it, and then just repeat it, replicate it however you want to do it, right? Lots of ways to accomplish this. But the bottom line is, follow these rules, right? Make sure that it's self-service to the developer, it contributes to quick root cause analysis, and mean time to resolve improvement. And it kind of looks like this, This is the one running off scans.gradle.com. You got a whole bunch of information in here. I'll kind of let you go through it. I was going to do a demo here, but we just don't have time. If you want to see one, though, Benedict at the Gradle booth will be very happy to walk you through every bit of this build scan. Or you can just try running one yourself. All right, what about these failures that should have been observable in the first place? This is actually, to me, the most important and impactful part of DPE. Because speeding up things is great, and making troubleshooting faster, these are all really good things, but completely eliminating sources of frustration from developers, completely preventing failures from occurring and flaky tests from occurring, that's the best. Everything's infinitely more than zero. So, pain point number 3. What gets measured gets improved, which is, I forgot to change the attribution on that because it was the same quote that I used from Yogi Berra, who says, you can learn a lot just by watching. Or you can observe a lot just by watching. But this is an ancient quote. This one goes back like hundreds, maybe even thousands of years, right? If you can measure a thing, you can improve it. Not just can improve it, there's an imperative there. Once you start seeing how bad it is, then you have an urgency to start fixing it. So we want to eliminate avoidable failures. We want to do this through observation and analysis, right? We want to decrease lead times by making deployment pipelines more reliable. We want to improve confidence in the correctness of changes and dramatically increase team morale, right? That's the point of making the builds more reliable, right? And before we get into that, let's kind of define the 3 types of failures that we're kind of talking about here that we want to be able to observe. The first is called a verification failure, and this is something that's like picked up by the compiler. The main point of this is generally the developer's fault. Right? So these are things like a syntax error, code style violation, something like that. But then we have these things, non-verification failures. These could be the developer's fault, but it could also be the infrastructure team's fault, right? Maybe you've got an API that you have to go hit as part of a unit test, and it's down, right? Well, you can't do anything about that, right? So it's a non-verification failure, but it's not something that the compiler was really expecting to happen. And slow builds, right? Just builds running slow, all right? That's something that we should address as well. So DPE organizations track failure rates. When failures occur in the build, they push that, and they centralize it, and they run analytics on it, right, to make it easier to understand the impact of these failures, right? So again, the kind of adage is, if I've got an hour to improve my build, where should I spend my time? Well, I don't know. Look through tickets and figure out who makes the most noise, or really actually track which failures are most impactful. For instance, if you start tracking this, then you can pull out statistics like 18 users were impacted by this failure over the last week. Maybe we should do something about that. Okay, so again, it's not really that hard to do. Build fails, write a little plugin that pushes the failure message into some database that has a nice visualization component to it, and do some aggregation. All right, and then flaky builds and tests. are maddening, right? We know this, right? I said in the keynote this morning that Spotify calls them the infinite pit of sorrow for developers, and it's very true. This is what we do, you know. And if you were in the Breeding 10x talk, you already saw this slide. If not, be honest. This is what happens, okay? The test is flaky. It's failing. All right, we're going to run it again. Failed again. Run it again. Oh, it went green. Nice. Accept the pull request, right? And we're going to do all these things. This is how we behave now. But this means that the problem compounds. More and more flakiness enters the test set. Less and less trust in the test set. Less and less morale. So DPE organizations analyze these things. They come up with ways to detect them. The simplest way is to just write your own plugin that every time a test fails, you go ahead and run it a second time or even a third, depending on how much time you're willing to spend on this. It's arguably that investment to be able to detect the flaky test will save you a lot of time in the long run. That's one way you can do it. If you're using caching, you can compare cache keys. If I've got two identical cache keys that are test tasks, and one of them had an output failure and one of them had a successful output, that's flaky. Throw it on a dashboard. Then make this data actionable. Right? Don't just, I mean, just having it there is great, but use it to make decisions. Okay? One of the nice approaches, and we have a blog about this, is to schedule a flaky test day. So this is a day when you open up whatever dashboard or visualization you have over flaky tests, you sort by test flakiness. How often was it flaky over a period of time, or what percentage of it was flaky? And then you just fix. The detection is the hardest part. And once you know for sure that the test is flaky, you can start digging into it and figuring out why, right? And then it's also good to just keep track of what percentage of your builds are failing because of tests, right? It gives you an idea of like a spread between when is the build failing because of some verification or non-verification reason, when is it failing because of a failed test. Pain point number 4, no metric or KPI observability. Are you tracking local build and test times? All right, I asked the question prematurely. Sorry about that. I got excited. I already know the answer, but I will say that the takeaway from this is that if you do one thing, if you leave this talk and leave this conference wanting to improve your build, and you do one thing from this whole talk, it's do this, right? It's not hard. It's so easy to write a plugin for any of the major build systems that can then just take that metric and shove it into a Prometheus database or some cloud storage or whatever, and then turn around and visualize it. Not hard to do that. It's an afternoon's work. And if you roll this out, the reason that I say do this is because this will lead to everything else, right? Now that you've got the data in front of you, what gets measured gets improved, right? Because I guarantee you, with some small exceptions, you're not going to like what you see, right? Okay. So DPE organizations track build and test times, just an example of our dashboard. Each of these is representative of a build. The green time is serial execution time. The white dot is the actual build time, and you can see we aggregate some more statistics here too. For instance, we're keeping track of how much avoidance savings we're getting from cache and incremental build, because there's our ROI on what we're doing. Take that savings of 6 minutes and multiply it by 463 builds over this period of time, and you can calculate a reasonable ROI. Sometimes called a cost of inaction. What's costing you now for not doing anything? And you need to focus on this and maintain vigilance, because problems will sneak back into the build. If you saw Brian's talk yesterday, you know, he had the frog on the edge of the pot, because that's that old metaphor about if you put the frog in the boiling water and you turn it up slowly, it won't know. Very much the truth here. You're probably not going to do one thing that adds 15 minutes to your build. I mean, you might, but probably won't. More likely is you'll make a series of changes to the build that add 5 seconds here, 10 seconds here, 20 seconds here, and before you know it, you've taken a 30-second build up to 10 minutes, right? But if you're tracking this, if you're putting it in a way where you can trend it and understand the thresholds and changes, then you can understand when the regression was introduced to the system, and you can figure out why it happened. Because most of the time, performance regressions go completely unnoticed, or they're noticed, but they're just unreported. They're like, oh, the build's taking longer. That's weird. Oh, well. Reported but not addressed. Hey, this build's taking long. Well, I don't have time for that. Stop complaining. And then finally escalated after they've already caused a ton of collective pain to the business. And so on the result of this, the average build time is much higher than necessary and continuously increasing, which is the reality for almost everybody, right? Who's not putting in DPE practice. So significant regressions can be detected immediately. Build scans are able to provide the capability to then debug what's going on with that build. So there's a collective, there's some, coordination that you can use across multiple solutions to come up to a better bit of performance. And then finally, inefficient use of CI resources. I don't linger on this too long. It's just more of a side effect of putting these things in place. If you think about the agents are going to benefit from the same accelerations, with the exception of predicted test selection. Then the agents are going to benefit from the same things besides predicted test selection because you're running all that pre-merge. And so if the builds are running faster locally, they're running faster in CI. So there's a good chance that your agents are going to be freed up. Not always. You might have had, like I said earlier, developers may just run builds more frequently. But at least that work will be more valuable. Okay. We're getting close to time here. I'm sorry that we started late. But faster CI pipelines, and also though I want to say reduction in tickets because of the build scans. We actually have companies who you're not allowed to open a ticket in CI unless you've already run a build scan and tried to fix it yourself. It's a pretty good rule if you want to protect your CI resources. All right, so in summary, we really covered idle wait time, inefficient troubleshooting, flaky tests, no observability, and inefficient use of CI resources. These are kind of the main pillars of this practice, right? And I don't want to say that like our product is the only collective product that provides these things, right? There's lots of just achieve these goals, right? So some quick next steps for you. The most scaled organizations, like I said before, they build centralized productivity teams. Uber has 300 productivity engineers. They're called productivity engineers, and they serve the larger engineering community. So all of these companies have established centers of excellence around developer productivity engineering. You don't have to get there tomorrow, right? We have a whole maturity matrix that you can look at, which shows you like, okay, where am I right now, and where do I need to be? And if you take the advocacy journey, which is this, you also saw cards for it at our booth. You can have a self-paced sort of course on DPE that you do at your own pace. It's totally free, and not only is it free, it's gamified. So for taking the steps, you get points, and you can spend those points on things like these awesome T-shirts and Legos and headsets and all kinds of cool geeky stuff, right? So no harm. Why not go through it? Why not do it? You don't become a marketing lead or anything like that either. But we will take you through, for instance, the maturity model. You'll get a chance to look at that. We'll take you through parts of the book. I'm going to force you to watch one of my talks, that kind of thing. And then also, we've got a very active community Slack channel. It's a mostly Gradle build tool folks, but there are a lot of developer productivity engineers in there as well. So feel free to come and join us. I'm always hanging out in there. Vincent's hanging out in there. We got a Gradle build tool engineers are in there. So yeah, feel free to join us on Slack and go in there and ask questions. And if you want to get a hold of any of us, we're going to respond to this a lot faster than like a LinkedIn request or something like that. I want to make sure everybody gets a chance. A couple of folks still doing it. Got it? I'll make sure that you get it later. Come find me at the booth. Okay. We have a book for this, 81 pages in its second revision. And you see Gradle on the front cover, but you won't see it anywhere else. It's very much a vendor agnostic book. If you're going to do the DPE Influitive gamified journey, you will come across this anyway. Okay, it's definitely part of the journey. Written primarily by Hans Doctor, the inventor of Gradle, but with a lot of support from other folks who are very productivity minded. And we are hoping to get a physical copy of this thing out by our summit in September. We'll see if it happens. And yeah, come visit our booth. Come see us, right? It's a live picture from yesterday. You can get some Gradle swag. Check out our world famous T-shirts designed by this man right here, Vincent. Have some excellent conversation, and maybe take a Gradle Enterprise demo if you want to. That's it. Thanks very much. I'm sorry we got started late, but I hope that was insightful, and I hope it wasn't a total repeat for folks who saw the talk yesterday. So thanks again for your time. And we really are at the top of the hour, but if you have questions, feel free to come to the booth.